Hi everyone, good day. Welcome once again to my YouTube channel. So today, please join me for another episode of Solving Mathematical Problem. Now, one of my students who wanted to take the entrance exam for UP and Ateneo, he sent me this problem in geometry he can solve, and he wanted my help about it. So today, I'm gonna solve it for him, and he also asked me to publish it in my YouTube channel, also for the benefit of other students. Okay, so okay, please come with me and let me try to help this guy out. So based on our figure on screen, we actually have a parallelogram. Okay, and here down below are its conditions. So the first thing we need to do is we must first establish the conditions given. Okay, so first it says there that angle ABC is 60. Now looking at the figure, angle ABC is this. So this should be the angle 60 degrees. Okay, another thing is this. You have AB is equals to line AB. This whole thing here is 2. So we'll place here 2. But at the same time, there's another condition here that says AE is equals to BE. So meaning this whole thing, this line is just being dissected into 2 equal parts. So therefore, this must be 1. And this one, I just divided 2, right? Another thing is, okay, if AB is 2, then definitely this opposite side as well should be 2, according to the definition of a parallelogram. And then this one here is 2.8. So AD is 2.8. Okay, let me place the 2.8 here. Okay. So now we have already established the conditions as given in the problem. But we can further place more conditions, but this time using the properties of a parallelogram. Now, according to one of the properties of a parallelogram, the adjacent angles should be supplementary, meaning they add up to 180. So if this is 60, this one here, this angle ABC, then by definition, this angle here should be what? Should be 120. Do you agree? That should be 120. Okay. Another thing is this. The opposite angles also of a parallelogram are equal. So therefore, if ABC is 60 degrees, then by definition also, angle ADC must also be 60. What else? Okay, this one. Angle BAD is 120, then again, by definition, its opposite angle must also be 120, which is what? BCD. Angle BCD should also be 120. Agree? So if angle BCD is 120 and we have a condition here that says FCD is equal to FCB, then meaning this entire angle here, this angle BCD, is actually just being dissected into 2 equal parts. So if the whole thing is 120, then its components must measure what? 60 each, right? Okay. So how do we solve this problem? Because we are actually being asked of this angle CFD. Now for me, all I need to do actually is just to solve for angle CBF. Why? Because once I already have the angle measurement of angle CDF, then I can already employ the definition of a triangle, which states that the sum of all the angles of a triangle must equal to 180. Would you agree? So, but for us to solve for this, we got to go through somehow a lengthy process for a moment. So first, let me solve for this line ED. And we will be solving line ED by employing the cosine law. Okay? So ED squared is equals to 1 squared plus 2.8 squared, all right, minus 2 times the product of the other two sides, 1 times 2.8, and then times cosine of what angle? The angle of which is opposite the line ED, which is 120. Okay? Next thing to do is let's just evaluate. Okay? Simplify. Let's simplify this one first. 1 squared plus 2.8 squared, you get what? 8.84. Okay, you may use your calculator at this point. And then this one, simplify this one. So you get what? Negative 2.8. And then simplify it further, you'll get 11.64. And then, of course, to solve for ED, we need to get the square root of both sides, right? To get rid of the square. So all you have left is ED, which is 3.4. Okay? So we have solved already for ED. That's again. Now, the next thing for me to solve is this angle, angle ADE. But since we have already solved for line ED, I can now already solve angle ADE by using the sine law. Okay? So I'll use sine law, the sine of angle ADE over its opposite side. Just so happen its opposite side is 1 is equals to what? Sine of 120 opposite, its opposite side is ED. And we have already solved for ED. So this is already pretty much easy. So to solve for angle ADE, so angle ADE, so that's just what? The inverse sine of what? 1 multiplied by sine of 120 all over ED. ED being what? 3.4. You agree? All right. So by simplifying this, I already now have the angle ADE, which is 14.76. Okay, that's good. We have solved that one already. Next is we need to solve this time. Okay, this time, let me solve now for angle FDC. And we know that angle FDC this time can be solved by how? We already know this one, right? ADC, we already have ADC, which is 60. So that is actually just 60 minus ADE. Angle ADE. And we have already solved for ADE. So therefore, angle FDC is equals to 60 minus 14.76. And your angle FDC is equals to, you use your calculator, you'll have 45.24 degrees. Okay, so see, we're almost there. And then lastly, since we already solved for angle FDC, this time it's already pretty much easy to solve for angle CFD. How? By employing the law of the triangle that says that the sum of all the angles in a triangle should equal to be 180. So therefore, by definition, okay, angle CFD is just equals to 180 degrees, the sum, minus angle FDC and minus angle what? FCD. FCD. which is equals to 180 minus 45.24 minus FCB is 60. So therefore, now our ultimate answer, the angle FCD is equals to 74.76. See, finally, we have our answer. So that's it, guys. I hope I was able to help you out, to my student. I hope this is more than enough for you already. But then if there's anything, to all my viewers, if there's anything that you want me to cover, any topic about mathematics, please let me know about it. Drop your comments below, and I will be more than happy to oblige to your requests. Okay? So that's all for today. Once again, this is Engineer Reagan. Bye.